Easy questions.
But for real, what if they ask a question that we don't know?
You just say you don't know and move on. It's not your problem at that point.
The scope of this research.
Do they know that? Be like, yes, we've been in this class, but we've been working on these
Well, I'll
projects
say I
for
don't
like
know, it's, you know.
a limited
I'll-
amount
I'll-
of time? Or do they think that we've been working on this all semester?
I like this picture.
I haven't barely started. I only have 2 slides right now.
Whom should I ask answer first? Oh. I would say what I would think and how I would practice on your side of trench, because I was an undergraduate student and much less advanced than you guys. I was like coming at best to the 50% of the classes and getting lower grades than you guys. So the task, this best thing is to avoid, like if you're challenged with a question, avoid I'm not very organized now. The wrong thing when you ask a challenging question is to trying to flip pages of your memory and try to remember something. This is very, very destructive direction. Just wipe everything off and try to think constructively, like, in common sense. And sometimes you feel the pressure and you think you do not have time, but then it is completely legitimate to request a definition, like which values of quantum numbers do you have? What is your definition of quantum number? And then while the person is speaking, you have a brief.
No, actually, why did you start that?
Yeah, but I have a list of quantum numbers that I use.
They would ask me questions. It's great.
Hinton asks me questions is scary.
Which David?
TA David?
Yeah,
David Grother?
Yeah.
yeah, because he always has this very
Yeah, he's-
specific look on his face when he asks you questions.
Oh, did you watch recordings how he was presenting? He was doing a rotation same as Patricia.
Oh,
The same undergraduate class.
No, I didn't. Yeah.
Here, I'm gonna pee my pants.
I wish I could.
Are you
kidding me?
He's just most responsible of the colleagues and ready to contribute to this
He
community.
really said he's gonna try to come.
do.
So good, we're gonna come.
I will send it, like I just run into him in the lobby and told, like, you know what?
Like this afternoon.
Mhm.
Cause I saw him at like 12:30 and he didn't say anything about
Is
it.
it like open? You know,
Is Bonnie coming?
It probably should. Mhm. Would be great if they come. I'll make sure that grad students from my group come.
Oh no.
Oh, the grad students can come.
Not David.
Of course David's gonna be there.
David's gonna rip my fucking presentation a new one.
But Sam, deal with anyone who asks you questions, same as we discussed with Eva. Just request clarifying definitions.
Yeah. What is the definition of the word that?
Definition. What is the definition of the word definition?
Yeah, define what you are
Tell me
trying
the
to ask.
definition of a wave function, and while you do that, I will consider every possible answer to your question.
Can you use it in a sentence? What's the origin of the word?
This is a spelling bee. Wave function. W-A.
B-E-T shit.
Can you write down a wave function?
Yes, wave function.
Sorry.
It's a bunch of squiggly
Oh,
lines.
wave function squared. Stop. Why are you drawing the rectangular?
If you square something, it becomes a square. If you cube it, it becomes a cube.
I love this picture that you added into this year because I know like 3 of these people and it's a really funny picture of them.
We should also have a photo session. I don't know if you are nervous, I will be more nervous than you and I may forget, but we need to like not forget to make
You'd be nervous.
Is that
your success is my success, your failure is my failure.
Make it one for the history books.
Let's reflect on Dimitri's teaching.
I know, but.
And as
you
we've
would think
discussed,
all
the
these
faculty
people,
members already.
like, could just tell it to you. You know,
Oh.
and then if we, mess up, then you tell us we messed up, then.
Then we failed with private.
But yeah, but then like other people are like, oh.
David presented at this class?
Yes,
Oh.
she was doing same as Patricia is doing now.
So if all my units are atomic units. Am I just allowed to say that all my units are basically set to one, except for, I gotta go back and see what like
Mhm.
and everything is just set like in relation to that. Everything is, relative.
It's very
So it
much.
doesn't represent like, we're not talking about like real numbers, like the millivolts or like, maybe it's not like entirely accurate, just all setting it relative and seeing like how things change just by changing this one thing. It doesn't represent perhaps like a perfect real world scenario.
True hair of ancient philosophers. Right, right.
Ava, you don't get to do that to me.
Huh?
Yeah.
Oh.
And by the way, you can ask questions to each other. And one of the ways, if you like very close friends and community you meet like very frequent, you can make it as a little theater show. Like
We can ask questions to each other, so we can ask questions we know.
few times with your questions, so that the foreigners will have no time for it.
Ava, how do you say your last name again? That's just gonna be like the question throughout the entire presentation. It's just
Re-explain what you just explained. Of course, right?
Yeah, they're like, can I look at that again? Oh,
Yeah.
nice, nice.
Oh, that's
But
good.
no question.
Just do the whole thing again.
There was about scary questions. There was a story about my doctor of defense. When I don't know if I need to tell stories so you have more fun.
Go ahead.
Yeah, we need some fun.
I did the defense in very foreign language, not in English but in German, which was a requirement, and I do not know German. Do little thing, but I was preparing, like reciting for a month, and then there were question sessions, and the room was filled with like a lot of my friends and supporters who were like worrying about me, and then there was a like really hard question, and I do not remember anything. I was so scared, so nervous, and I just tell the story just from the words of my friends. That of like his face became white, then pink, then red, then purple, and the time is clocking, is already 2 minutes, and then he answers, yes. And all friends were exhaling. I have understood your question.
Yeah, thanks for presenting in English.
That's scary to me because for a while I was considering going to do my PhD in Germany. I don't know any German either.
Yeah, I wanna
You don't need it. I was approaching my advisor and telling like, would you please permit me to write my thesis in German? Please don't. Please. But if you have serious questions, I'm at your disposal. Yes.
I do have a question, which is that, oh, that's not for this computer. Did you have any comments on my report. Cause you didn't like send me anything other than the initial like email after I sent it.
It's so advanced. I'm not, I do not think I have sufficient IQ to criticize it.
Okay.
But I like that you see the dependence of the Schrodinger cat size on your like amount of pulses. What again, I'm not chasing the level of being a criticizer, just as a curiosity. Why don't you try to summarize it in a table or in a graph, like how the final width of this like the code maybe computes the dispersion of overall wave packet, and then put this final dispersion as function of the parameter, like number of pulses.
I wasn't sure how to like get that in the table. Like,
If you have this data, getting it in the
Yeah.
table is not a big deal. Have you seen the work of Fred?
I have not. I have heard explanations about it.
I actually was.
Read the classics. I'm pointing. So he has a parameter like dielectric constant, and as a function of dielectric constant, he records the width of the wave packet at the last stop of the simulation, right?
Yeah.
And it looks interesting. Oh yeah, this may be not the very last version. There are some cosmetic changes, but Fred's work is not dramatically changed.
The stuff that's in there, like the blue lettering, that's not gonna show up in the book, right? I don't think there were color pictures in the last one.
Right.
It would be like gray.
Oh, yeah, I guess so, but I don't
But
know.
I've asked
It's like an equation and not text.
I have asked to remove the. So here is the equation.
Oh,
Hit-
you asked me to remove what?
Not you,
Oh, okay,
the publisher. I've asked them to remove any highlights on the text because
Okay.
Oh, so that is my part.
but not in well, just mimic the actual. So you see, this one is a little has some width, and it is shorter than the size of the box, and then it tells like solvent, dielectric constant, and the
Oh.
width,
Okay.
and then he even summarizes it into the dependence.
Okay, yeah, that makes sense. Frederick, may I come talk to you about your
Sure.
stuff? Okay,
Oh, man.
thank you.
Oh, pleasure.
I haven't been answered. What is it? To be honest, so
So,
all of Goose numbers are from the data brush tool. And I went in. Very, well, yeah, that was the easiest way to do it, because I couldn't figure out how to get like the width of this wave packet, like in a number. So, yeah, I kind of just, well, if you go into any of your graphs, there's this like symbol up here.
Absolutely, I understand. So
Like this.
did you put reference at the bottom of the page? Okay, so you can. I'm thinking clearly, and I know what I want to say. Just trying to
What are you trying to
convert
measure?
thoughts into the.
Oh. I don't know. I mean, if you,
Just a second, Fred.
I mean, yeah.
Like if you look at the last instant,
oh,
her wave packet is consistent of two peaks, but
Oh,
if one makes a width of everything, it will be basically distance between these two peaks. You see, in different simulations, this distance is like either negligible or getting bigger, and there are unique cases when they become really big, and it is something interesting and potential.
Dotted line is like the middle
that's
of
the
it.
average.
Middle and average, and there is a width, right?
Yeah, if you go into like
So
the little paintbrush.
one can
think that would be a
put details into the slide, backup slide after the conclusions, that you will show only if there are like challenging questions, and then
Oh, and then
you just
maybe, I don't know.
go
I just
over
took
and
screenshots of all of mine, like
tell
after
what is what.
Like it was
Mm.
open in MATLAB. I did it.
Do you have a copy of it or make a copy because I can mess up something? Just save
No,
as different name.
honestly, you could probably just do it like with a. I would. That's what I basically what I did. Like,
I'll show you. Let's see the.
Okay.
Yeah.
That's good. That's good. That's Control C.
But then you just estimate by like in terms of bond length.
Yeah, but I don't have.
You just like draw a straight line down at each of these. See that, you know what I mean?
Yes, there's a ruler on the. There's a ruler on the program.
Oh,
Oh, wait, this is.
pretty sure you have a question. Is that our? Do we get to keep a copy of these books, Dimitri?
You will.
So I can show my mom?
Oh, yes, yes. You can even write a dedication.
Wow, that's.
You should have put dedication like to the above the title.
Oh, dedication to my mom?
Yeah.
Oh, okay.
Or an acknowledgement.
Merry Christmas. That's what I.
Or an acknowledgement. I acknowledge continuous support of my dear family.
I acknowledge that I made a massive mistake
yeah, we're putting out.
by challenging myself with this major.
To Dimitri, to Sibel, Bryn, and my mom.
Yeah. I'm so happy. I'm gonna.
I'll
see
just
my
spend a
mom.
good chunk of the time being like, thank you to Fred. Thank you to Elsa. Both
Their
are-
last names too.
Oh, there we go.
How do you say your last name?
Jolai.
Okay.
Gioli.
Never
No,
would have
it's
guessed
not
that.
Gioli.
It's Gioli.
Everyone says that. That sounds too Italian.
Gioli. Mamma mia.
Ravioli.
Spaghetti. Oh, wow. Well, have fun coming home, you guys.
Stop.
Did it start snowing?
I think so.
Man.
Yeah, it's
Walking back.
It's not.
Oh, I want to try. I want to try other universities.
it's something. Let me just tell you that.
She's fine right now.
Is it?
Yeah,
Okay.
Just-
side streets are gonna be horrible.
Show an
I think
example,
I'm
then
gonna
we
have to
can
go up
continue.
Albrick.
She'll be fine.
What is that? I might get stuck.
Is there a draw? No.
How do I make this a superscript?
Equations or in PowerPoint,
PowerPoint.
Walk where?
but you can do it in equations and then copy paste.
It's for my title slide.
And I for so long. I'm a shovel.
Wait, in my old car,
Oh,
but I don't have it anymore.
oh, I got a new shovel. It's blue.
You gotta keep a short.
I don't.
I'm old.
You need a winter survival kit.
Oh, I have a shovel. I have like a jumping cable
Yeah,
kit.
yeah.
Water, my hammock, the essentials. Oh, peanuts. There's peanuts in the back of my car.
There's what in the back of your car?
Peanuts. Peanuts.
Oh, oh, okay.
Stop.
Come again?
How would that even?
I think the way.
I am sleep deprived.
like-
TYBSM.
No, I don't have that in my car. I prefer that not to ever be in my car.
I'm confident.
Oh God.
It's actually better than I found by now.
Why are you the way you are?
You guys like my
This part of
Santa?
Hamiltonian
My
corresponds
Santa
to
emoji?
molecular elongation.
Yes.
This part corresponds to the
I like
electric
that
field,
Sam's bit
and this
more
part
like
corresponds to the
there.
coupling. And then if you want details, ask them in the question sessions.
Can you see them, Fred?
Okay? Does it answer your question?
Yeah, I see
And then you can
see mine?
condense
Yeah, I see.
complicated stuff in
Okay, well, I just
20
can't
20
see
seconds.
words. Or melodies.
Oh, yeah. I don't mind if only a few people can see my stat maps.
I like how it says elf. Under the Christmas tree for a while, but Santa kind of slaps right now.
Yes.
You can see my bit.
Thank you.
I understand it very clearly. I'm just trying to find right words to explain. Probably,
There you go. Now you can stop.
red can help us.
Great.
Oh, my God. I don't
So-
know if I can help. So,
So the total energy of molecule, not only vibrations, but total energy of the molecule is composed of energy of electrons and energy of ions, right?
Okay.
And then Fred, listen to me and then try
I'm
to
listening.
thank you. Try to translate it in more understandable language.
okay. I'll try.
So I'm just know what you're doing. So if one changes interatomic distances, right?
The
And
options are
then
weird.
these interatomic distances change the potential. And in this potential, one can resolve electronic degrees of freedom and solve Schrödinger equation, find wave function. And energy of wave function will be different.
I mean, I'm sure that.
Even you're not monitoring how energy of your
Yeah.
electron in the polaron is changing, but one can monitor at each step and see if it gets like lower or higher, probably lower. And then total energy of the molecule is an actual Coulomb repulsion of ions, what you model just as the Hooke's law.
Okay, yeah.
Plus,
That's the,
Like that I do.
the bright green things, the loops, the peaks, or no? Can you actually?
pointed on the,
No, it's neither of those. I don't know what that is.
Like here. Like the force between, yeah.
yes.
I mean, I know the
Right,
the equation is in there,
Right
yeah,
here, yes.
yeah.
So,
Like I'm talking about.
so continuing for Patricia, the energy of the whole molecule is like energy of electrons, energy of ions, and energy of their interaction. And if one wants to be precise, taking into account only interaction between ions as point charges is insufficient. One needs to take into account interaction with electrons and ions, right?
Mhm.
So here in your Hamiltonian, you have kinetic energy of nucleus, you have vibrational, which is just the ion to ion attraction plus energy of electrons as function of interatomic distance, because if one changes interatomic distance, energy of electrons change. Why these authors want to do this? They want to step above the modeling and connect their calculations to computational chemistry, to additional programs that compute electronic structure and be a little bit more precise. And enough, or we need a translator?
I don't know if I'm.
You are.
I don't know. I think.
Okay.
Low key, it's kind of like what I'm wearing today.
Yeah.
Except it's not too tough. And where the
And do you plan to include the dynamics? Good.
It's very.
Tiny bright girl. That's like the kind of matching set from.
Yeah,
Pakistan.
that's like.
Tell me what tolerance.
It's like
is.
what's
Mhm.
Korea.
Oh, yes, with great pleasure.
Show this. Mind dynamics, right? Yes.
Run it so that I see how it runs.
You work.
Yes.
And I also don't like the background noise we have.
But if you make everyone to think that it is crazy, it's good.
I understand like. I understand, I think I get most of it, but like, I don't know. what tolerance is, but
Okay.
tolerance is here.
I will happily answer, but I feel that everyone else is bored. So first, can you explain the figure that you want help in understanding, and then I answer your question. So that the rest of us do.
Oh. Well,
See tomorrow, but summarize which figure. Like,
I guess there's a schematic. Kind of like a flow chart modeling how my code works, where potential between like an electron and an ion is set. Then the probability density of that electrons, or the electron density, which I wouldn't think is the probability density, is determined from those forces. And from there, the code takes that density and updates the position of, well, it says position of ions, but it's the electron, the polaron that's moving in the polymer. And then from there, the tolerance thing comes up, which I'm not really sure what exactly it means, but the tolerance is supposed to be larger than what is that? The yeah, okay. That's like, oh, that's like delta E, like,
yes.
I see.
Okay. I've told you you're not bored. You are most entertained now after listening to Fred.
Yes.
I thought so. So now an illustration that you probably should like. It's an anecdote, and I feel sorry because I'm telling it again and again in each class. So it's repeating a joke is not a joke anymore. But maybe if you haven't heard it before. So a company hired a programmer, and he was working well. And one day he didn't show up to the work, and like company started worrying, like he's not showing for an hour, for a day, for 2 days, and then they sent a delegation, like several colleagues knocking to the apartment. The door is unlocked, and most important that it is a programmer, algorithmic thinking. And then the door is open. He's sitting in a bathtub, all blue, with shaking heads, carrying the bottle of shampoo, and apply to head, to hair, rinse, and repeat.
I like that one.
So if you have some repeating algorithm, you need some like breaking, like a way to stop the algorithm. Like we all are doing in the dynamics, we repeat, we can do the same flow chart as Fred for dynamics. Like take wave function of the past, apply evolution operator, rename our future as a little past, and repeat. Go by little slices. And then we stop when we just repeat it n tau times, like 500 times, and then enough. But Fred, instead of doing dynamics, he is doing optimization. So he needs to find the energy minimum when system stops. And the way one can do like 10 steps, 100 steps, million steps, but who knows when it will stop. And the most correct way would be to compare total energy of the system at previous step, at next step, and see if they become equal or almost equal. So the degree of their offset needs to become smaller than predetermined tolerance limit. When you were taking calculus, I'm absolutely sure you were not able to go through it without this boring and disgusting theorems. For any infinitely small epsilon, there is blah, 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 right? You remember this?
Yes.
At least you remember the language. So one sets a tolerance limit, like convergence limit, and then puts a clause that something should happen even if this tolerance limit is small. So in Fred's case, the system should converge even he requests high precision. Tolerance is a level of precision. If one takes very imprecise tolerance limit, it will converge in a couple of steps earlier. If he puts a smaller, then it will run forever. And even if this portion of the code is not well programmed, it is how it should be in general. And if one makes this thing as a profession, it needs to be like focused at.
So the difference in energy from one point to another of this polaron has to be smaller than the tolerance.
Yes. Yes.
That's set in the code for it to be like recorded as a data point.
Mhm.
Okay. All right, thank you.
And
I'll put that in my power.
if you will be yet in the program in spring 2024, you're very welcome to take computational chemistry 476. And this flow chart that Fred did describe right now will be the main portion of this course.
2024 or 2023?
24 in like a year, not like in a month, but in a year.
No offense, but I hope to be gone.
It will be a big loss for all NDSU community.
I appreciate you saying that.
Who knows? Maybe you'll try a secular life and then decide to return.
I mean, honestly, if, I don't know, not that it matters at all, but if I don't have children in the future, I think I might return to school, yeah.
Talk
Because that'd be
to
like the main thing, like if I have kids, like there's no way I'm just gonna go back to grad school, and, you know, drop everything to do that, like, at least for me, you know, but if I don't, then I'm free to do whatever. So maybe later on, if I'm feeling bored, sure, I'll come back.
you will be very welcome. So Landon Johnson, who will probably attend the meeting tomorrow. So Patricia knows him, and Sam knows him, right? You like not very many pairs. So he was performing outstandingly in this class and doing research as an undergrad, and then he declined to apply to graduate school and went to like outside work for a couple of years, and then finally he decided that he wants graduate school at NDSU. So there is a live example of this philosophy.
Teacher, I have a question. So are the energies for the eigenstates negative because we're in this like negative region? Or why?
How do I know what topics?
Do you know what I'm talking about?
Absolutely. I have clear vision, clear answer. I just trying to convert words, convert thoughts into words.
Okay.
Can we go one slide back? Okay. And do you have a copy of this slide, of this PowerPoint? Maybe save it under different name because I fear to modify something and screw the good work.
Okay.
I'm a little paranoid, and therefore I garbage my computer with like 48 versions of each document.
Make copies?
Yes, save as and tell like best presentation number 2.
Okay.
Okay. So let's just temporarily enlarge it.
It's my outfit.
Nice.
Oh. Okay,
I'll put myself. on
please
there.
tell me what do you see?
Well, there's a sort of negative region here. It's the negative,
So
I don't
you,
know if it's a negative potential, but
yeah, good. Potential should be negative most of the time.
yeah.
Our universe would explode if we wouldn't have negative potentials. Sam, are you here? So our universe would explode if we wouldn't have negative potentials.
Same.
The negative potential means things are attracted to each other. Like Coulomb force between opposite charges is negative, and it means it holds together. If the molecule has too many repulsive potential, if overall energy is positive, it means it is unstable explosive. So all stable chemicals should have negative energy if one does it like either physical chemistry modeling or computational modeling. And it has connection to your project, because if you wouldn't do antisymmetric Slater product,
You'd only get positive integers.
you like if you do Hartree product and find Coulomb matrix element, it would be not simply positive, it will be infinitely positive. That cannot be compensated by any attraction. And it is a history of computational chemistry. Each molecule has many electrons, and the first person who was trying to make theory was Hartree, but he failed because he just made a product of wave functions. And then by his calculations, the result was that any single molecule in our world except hydrogen atom should explode.
Okay.
And then the Fock, it's a last name of scientist. He suggested that one needs to borrow the wave function from Slater, use Slater determinant for multi-electron atoms, and then most of atoms and molecules become stable, much less explosives. I don't know why I'm telling this story, just commenting to Eva that negative potential is very good. Like one shouldn't worry, one should like celebrate if the potential is negative.
Okay.
So you do see a canyon, right?
Mhm.
Now, yeah, let me play my role of entertainer. Because I feel like if I'm speaking only to one person and others are bored, it's my favor. Maybe I'm missing profession. It's probably attitude of a clown rather than instructor.
Do you hear about the recent news regarding fusion?
I've heard that they exist, and I put it aside as a little dessert to read later. So I'm looking for the marker. It was.
Oh, it's your pocket. Oh, yeah, it's in this pocket.
Thank you. I think in academia it is forgiven to be a little absent-minded.
Okay.
Oh, thank you. So we will return to Eva's problem of two-dimensional potential, but let's do an arbitrary potential, which is not necessarily harmonic. So one can consider potential like the energy. Typically, this is position, this is potential energy, and this is zero. So if energy goes to 0 and above, it typically dissociates, it breaks on pieces. It's just common observation. And now we do have some like -10 of some in some units. So this well or this canyon can be just, if you want to translate quantum theory into the everyday symbolic objects. Suppose we have a little dip or little cup, and we are pouring water, right? So we pour certain amount of water, and it comes to a level. And suppose we have we can put only like full glass, 1 liter of water, one like whatever aluminum can of beer.
Okay.
So then I put another aluminum can of beer, and then it comes to different level. Then I put another can of beer, then it is another level. So cans of beer are like quantum numbers,
Okay.
and the level how much beer will populate this ridge are eigenstates. Okay.
This is right up front now.
Okay.
Yeah.
So number of quantum numbers, energy level, like how much this beer will populate this well. If the well is narrow and deep, energy offset will be big, right? But if it gets shallow, then even if you put many cans of beer, the offset of energies will be really small. Like if you add can of beer to the world ocean, its level will increase by infinitesimal small level. Okay. Now I'll return to Eva, but our discussion will be based on this analogy.
You got that, Fred?
Yeah.
Now, please tell me what do you see, and especially those invisible things and this little planes.
Explain it in beer terms, please.
I'm assuming that like this is the
wells that you drew. Okay.
So the diagram there was one-dimensional potential. You have two-dimensional, but the analogy still works. And those 3 planes are 3 levels,
Yeah.
lowest levels.
the lowest eigenstates.
Okay, and the shape here shows where they are. So this, you see, making,
These.
yes, you see how they fading and they are very hard to observe. So it's conceptually great, but visually poor.
Okay.
And therefore, let's go back to editing mode. Thank you. Therefore, we are looking at them. By looking from the top, from above.
Excuse me.
Oh, she is. We asked her.
By the way, if you'll send slides to me, right? They will be run on the public computer. So I know that for saving space on your personal computer, you are trying to embed YouTube videos, some of you. But if instead you directly insert big movie file, it will be more reliable. It will eat up a lot of space, but it will be more reliable. In one of the classes in the past, a person played this YouTube video, and then we went to discussion and forgotten about it. And the sound on the computer was muted. We didn't hear it in the class. But then when we started recording, it went to some fun ethnical music with laughter sound on the back. And the second half of the class was not actually recorded. Like students are coming and showing diagrams and din 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 ha 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 din din din.
Lab, when you and I were talking about my project,
the audio spikes were on, so it picked up everyone else's conversation about Spotify instead of you talking to me about my equations.
Mhm.
So I was,
So how do you embed it as a?
Insert.
Just
Insert
insert
video.
video on the computer.
You just download it straight from YouTube.
Yeah.
By the way, if you download straight from YouTube, the video becomes optimized. It becomes like 50 times thinner. Like if you're, especially for Patricia and for Eva, your files can reach up to gigabyte, right? Which is a killer for computers. But if you upload to YouTube and then download back, it becomes like 20 or maybe 50 megabytes, which is a little better. And one can refine, even upload and download once again, and then it will become like 2 megabytes. But let's postpone this technical thing to the future. So if you remember how it runs, right? So the first eigenstate will be about here, right? And it is above the deepest part of this canyon. It is the lowest level of beer being poured into the canyon, and it has a single hump, same as for ground state in any system. Is just single hump camel without any nodal points on nodal thing.
Yes.
When you
Yeah, just measure it, you know, because
You-
they don't know if it's exactly
whatever,
right.
when
or
you go
not,
to the second one, it will have probably
as long as
one
it's
positive,
more
one
or less
negative,
right by eye.
and it will still be in the deepest reach. When you look for the third one, probably it will be this one, localized in the second less deepest. It's more like this is intermediate, this is product of reaction, and then the rest will develop like hybridized orbital between here and there with more and more blobs and nodal planes. I'm talking too much. It's much better to like interview this little.
So this, like these, it's in this region, like of this graph because of this negative part.
I'm going to show the actual dynamics, not the movie of eigenstates, but actual dynamics. This is what I'm expecting.
And what is that, like the
You-
full run?
Yes, you do have them on YouTube, so
Yeah.
I know you're capable. I'm just no criticism, no objection. I was just a little surprised. You generated like 6 of them, and you mentioned none of them in the paper. And now I see you're not trying to put them into.
I don't think I think the videos would be fine, but the graphs like come out illegibly in picture format. Like the line, the actual like path
So
that it takes like disappears.
I understand your complaint and confusion, but this attempt to convert video into like still movies is a standard thing that we try to address. But the fact that the technical implementation of the idea can be below standard doesn't mean that we should cancel the idea. You can blame instructor, computer, software, and tell, but my idea is beautiful. Yes. Was it a raised hand or a dance?
Oh. I want to decide what video it is. Right?
I understand the question. So I wasn't watching all of your videos, but I assume that you do have a parameter, for example, number of Rabi cycles.
Yes.
And by scanning parameters and looking at the videos, you have extreme when there is like only one, extreme when there are 10, and maybe intermediate. And you have either most representative that has features of all, or you have very limiting cases that show dramatically different behavior, and everything else in between can be fit as continuous change. Did I answer your question?
So you're saying I should pick the one that is most representative of it?
Or two most polarized that
Okay.
most surprising. So maybe I was too sharp in telling, like, no matter what scientific meaning, just put some video. No, it's not the end goal. It is just a tool. And I think Melody did in her paper an successful attempt of representing video by still images. So she did just several snapshots.
Yeah, that was a very handy tool on the computers in the library that my computer does not have, which is to just take an image straight from the video. I don't know why my computer can't do that unless I physically press the screenshot button. I
Every-
wonder if I put
Your
two
question
things
addressed?
at the same time.
I will not take responsibility for telling yes, but why not?
I'll try it.
It's not a scientific question, but question to a programmer who is still sitting in the bathtub.
So then the energy is negative because the potential is negative.
Yes, because if you pour beer into the well, it will be below the ground. Probably I'm not sounding very scientific, but hopefully convincing.
Yeah. Is this a good video though still to have?
Yes, because without this video, it would be completely unclear what is going on. So
Yeah.
even you tell you I'm borrowing this video from previous generations, but the parameters from here help me to solve my problem.
Okay.
Well, scientific problem.
Yeah.
I'm fine. I do not have problems. And those energies are not energies of a harmonic oscillator, right?
Yeah.
Okay, because in the original version, it was, so it should be inserted as video, not as image.
I didn't take that. I just.
But you, oh, okay. Thank you. Okay, if it were, oh, turn to Melody, just a second. Let me. Yes.
I think
No, let's.
it might be an issue of it's two videos on the same slide. Unless it'll like play one after the other. maybe.
What if I am extra careful to pause the video before I go on? I just want to insert the YouTube video.
Make sure when you are done, make sure to close the browser. Right?
It shouldn't have to open its own whole browser page. though.
It just opens a little
Yeah, on
on
PowerPoint.
your screen and then I'll play it.
And
I'll probably set it to like go to twice the speed anyways, because it's so
you can
slow.
do both. You can insert as actual video and put a link to YouTube on the same page. Like make a backup. If one doesn't work, you try another one.
Okay,
Because it,
I think I know what you're saying. Is this what you're looking for? Like, just in the slide, I go and present it and play it.
Mhm.
This,
Mhm.
okay, all right.
I think this one, no, this one's on open, and this one is just not.
Like this, so. So.
But if you try
Have like a
things,
slide,
you
wanna insert your YouTube video, you just, you know,
Yeah.
I don't remember what I did, but
Right, you try things until it works.
exactly. I wanted to say something possibly smart, but I forgot.
yeah.
So, things are clear on your side?
I said I forgot you already have.
Oh, yeah, about technical things. I wouldn't instruct you how to do it, but just as a user and observer, if one converts a video into GIF image, then it will self.
That was weird. It just exited out and then popped up again.
I'm not super far along with mine. It'll get done though. I mean, it's really just a matter of summarizing my paper.
Mhm.
Right?
Exactly. Mhm.
This one clicks.
Did you watch the video of Braden when he did the seminar?
Okay, they do.
Okay, so we don't have this advanced video, but you remember what he was showing, like when atom is moving and the like field starts glowing like strong. Mhm. Well, by the time you go from this little class exercise to more serious things, maybe you will learn how to do such things. Because it's kind of very explanatory.
Okay.
Sam, how are you doing? Any questions, or you are good on your own?
I'm just kind of existing here right now,
Okay.
which is my way of saying that I have just been listening to your beautiful conversations and trying to gain the energy to actually be a productive scientist for the night.
Okay. I'm with you. I'm trying to perform the same way.
I shared with you the presentation. Even though like I haven't truly changed it. Here.
I'm sure almost everybody's will go over 5 minutes.
Let's see here. So we'll put this here. This here.
I have one more. Yeah, but it's online. I can take it whenever I want though. That one I'm not worried about. This I'm more worried about.
Yeah, here.
Yes, that is the sole reason. Literally,
These are not the same. Here we go. Okay, so we're gonna have that and that.
I'm just watching your slides.
Sure, yeah, I'm just kind of what I'm probably gonna do is because yes, that comes in for I think that's probably a little more important there. I'm just trying to format it right now.
Here's my question, like this particle in the box, they're correct, there is still
So the way I was gonna do it is because
but if you can avoid them at all, it would be really making your presentation much shorter.
yeah, as of right now, I'm currently up to slides 1 through 5 are what I'm going to actively present, and then I'm going to probably have the particle in the box in case I get those questions, just to be like, all right, I have these like slides already up here, like I'll just quickly get to them to kind of explain it. But if no one, if no one asks me that question, it's just so like here, I'll I guess to end it off, I will probably just right here is where my like not the nope, come on, up more. Right here is the questions.
Where should I look for questions?
Question time is slide number 6 right now. I just added it. It should have gotten moved there.
Are there like questions below the presentation?
No. Like I just have a slide that should now be it should be between what is
Oh, okay.
your 5 and 6. I just added a slide that says questions.
So,
Let's see here.
are you accepting constructive criticism or you?
Yes. Yeah. As of right now, this is kind of just, I'm kind of just going to go based off of my paper and what I have. I should probably actually use that figure instead of this one.
So right now, the present version of the slides does miss any equations.
Okay. So put some equations.
And the main
Let's
equation
see
is
here.
Slater determinant and explain
Yes.
what it is.
That is the, let's see here, the Slater product. Where is this in my paper? I have the cone-sham equation, the 3D converted to 1D, the heart tree project. I have the matrix element of the Coulomb interaction in terms of Slater product. Here we go.
I have a question when you have a moment.
Okay.
But I don't know if yours would be.
Sam, would you accept another comment?
Yes, I'll take anything you have to give me.
So, if you could make an analog of this figure in terms of defects at nanotube, it probably would be most illustrative. So if you do Hartree product of one type, Hartree product of the opposite time, and then subtract, and then show this thing. So do you understand me?
Yes and no. I understand what you're trying to get at. Is the is the Hartree product within the MATLAB code? I just have to figure out which here, which figure that is. Because I might let's see here. It would, let's see here. That's not going to be the Hartree product. That's just going to be the Coulomb. I believe that's the Coulomb.
I can be wrong, but I believe these two images that I'm highlighting right now.
Oh,
they are two Hartree products.
Well, then that would be. And so then does that mean that the bottom graph?
If you take this one, subtract this one, then you'll get the
okay. Yes. Yeah. And that's what I was gonna say. I have that figure. Not the like the two independent. I have the combined like Slater determinant as two figures of the paper here. Let me put it. It's actually if you go to slide 4, those are the two.
Yes, they will.
Those are like the product, the Hartree or the Slater determinant with the Hartree products. So if you want, what I can do is I can take the two Hartree products and put them above like my A and my B, and being like, hey, A is going to be when it's, you know, the single bond distance away. B is going to be at the 2.5 nanometers. Is that kind of?
I don't think so.
Okay, so then I'll get rid of this figure. I'll quickly run the A figure. There we go. Let me quickly. Is A already the one open? It is not. Reedham, Slater. And then why are you so big? That's what the great bad wolf said.
If you put like minus and plus, minus and equal,
Sure.
And then one can maybe use the same.
For the earlier one.
They are
Equations.
But if one would do, I'll draw, but you can probably put it like phi 1 x1 times phi 2 x2. So it is this box minus this
Sure.
one,
And then phi 1.
2 phi 2 x1, and then will be later.
All right, cool.
I don't know, I mean, I
Okay.
guess it could, how many slides do you have?
Okay, yeah, I think you are in a good standing.
All right,
Cool. All right.
as long as
So I'll go ahead because there are other questions in the class, but
you're after
attract my attention if something is needed.
part of like,
All right, I'll scream.
and what the pattern was, you know, and then beyond there, like, then you can just get it. So you want. But I guess, yeah,
It's fine.
I'm sure it'll be fun. Yeah, I mean, it's not really like a super bad thing if you go over.
I have forgotten my question was.
I'm sorry,
Oh,
you were speaking so loud.
okay. So in my presentation, can I show this video and refer everyone to the booklet for what all the lines mean instead of including the chart? Because there's a lot of words in my description.
You're a free person in a free country, but it's not common.
Okay.
Like you come to the conference until you will not understand my presentation if you do not purchase my book, which is worth of 300, and do not go to the page number 253.
Okay, so I'm not allowed to cut corners. Okay, I got
You
it.
should, I guess.
Or like
But you're a free
instructor
person in every country.
comes to the stage and tells like, the subject is harmonic oscillator. Open your books that you presumably have purchased on the page, and I'm going to comment on the equation number 43.
Okay, I
The
get that.
Students will love such instructor.
Yes, that answered my question.
Dimitri, I have a question now.
Mhm.
I have a couple things. I'm not really sure what to do with this. In part because it's 5 minutes long and you're gonna like do time speed is like 2 minutes long. But also this. Like it doesn't really complete any sort of like dashed path. You know what I mean?
Mhm. Mhm.
Which, yeah.
Again, if the system, the model do not follow your expectations, it's bad for the system, not for you.
Okay.
So this is a mini research term project that was done within 3 weeks. So if any of you get something truly competitive, it will be like big wonder worth of local and national news. So you just do your fair attempt.
Dimitri, you mentioned something. You said if your model does not follow your equations, how will you say that?
Yes.
It's the wrong way.
So I will continue. I just so when we were discussing like ancient, not philosopher, but ancient speakers like Cicero, before you wrote, and we discussed that one can, in your paper, you can arrange it, and the introduction you put hypothesis, then like methods, results, and the conclusions you tell how far your hypotheses were confirmed by the methods. And for fair scientists, it's completely okay to say like, I was expecting this, but then I did my fair job on putting equations and programmed them, or I like took a spectrophotometer and made measurements, and they went completely different of what I expected. Let's think together by the whole global scientific community what it can mean. So it's good if hypothesis is confirmed, but even if it is not, it doesn't affect you as a scientist and doesn't affect your service to the scientific community. It's like a traveler putting marks on the tourist trail. Like, do not go there. there will be, you fall down from the rock. So do not worry, do not take failure of the method as a personal failure. You just explore unknown areas. Make sense? So the way
I see it, the more over time you go, the less time people have to ask me questions.
Brad. No, it's infinite time for questions.
Oh, alright, sure.
You know,
But the people, the audience is gonna be like, alright, like.
We've had enough of you.
Yeah, exactly. I don't want to hear you talk more.
But then if Melody needs to go to the differential equation exam, and you and you speak for two, and you speak for 2 hours, and she suddenly finds a gun in her purse.
Oh. Yeah, you never
Right.
know Melody.
I am experienced with a gun.
She's lived in Missouri.
Like, I'm sorry, I need to go to exam.
That might happen, everyone.
Yeah, Fred, watch out.
I don't know if the following joke exists in this community, like armored people are polite people.
Let's try to.
So you can use a little over, but take it.
It's not my goal.
Okay. You can go to the station. Melody, do you have a gun with you? No. Okay, I'll go for 2 hours.
You can dodge it.
So the potential, right, can be explored by 2 major ways: by classical mechanics and by quantum mechanics. So classical mechanics means that each particle, each bond length, each parameter is just point charge, right? And if we would explore your problem as a in frame of classical mechanics, we will just put a point and let it roll downhill. And then it will make a trajectory, and because it will accumulate kinetic energy, it will climb out of this well and go to the product. And it will be a single pass, single trajectory. If we allow probability, I know what I want to say, but I try to entertain and do something on the board. Okay.
Okay.
But the question that you are asking, you're not alone in thinking and worrying about it. And it is a very deep thought that was practiced by and partially addressed by another Nobel Prize holder, Richard Feynman. So Sam is heir of ancient philosopher, Greek philosopher Socrates, and you're heir of the modern Nobel Prize holder, Richard Feynman.
Okay.
By posing this question.
So should I just include this video? Though,
Oh yes,
no, it looks bad.
right. And here are some comments on interpretation. So here is your playground, and I can draw the your canyon as geographers do. So this geodesical lines mean it is deeper, deeper, and deeper, right?
Yeah.
So it's okay. You're fine with it. Now, if we would put your reaction, your like point charge classically in certain point, it will go downhill, accelerate, pass the minimum, then pick up speed, then it can oscillate between these walls of the ridge, and finally it will go out to the product. from reactant to the product. You're following, right? Now, instead, you have a distribution. Like it has probability to be anywhere in these regions. I'm going to say something that will scare myself. So, are you attentive?
Yes.
Okay, good. So this distribution can be interpreted that we have a swirl, like we have not only this initial point, but for example, this one, and we can take classical trajectory when it goes downhill, maybe going slightly different path, again reflecting, going and also finding to the product. Then at the same time, there is another trajectory that if you go here, it will start going between sides of the canyon and maybe go to the product, and maybe it will be trapped there. So distribution, your initial wave packet that has this Gaussian two-dimensional shape, means on the language of classical mechanics thinking that you have a swirl of trajectories that have different initial conditions. Okay, some of them go from reactant to the product, some don't. And then if you switch on quantum mechanics, it means we will, our very first 3 lectures, we will assign classical action to each of these trajectories. And at each point of space, at each point of time, we will add these trajectories with this E minus I H bar S. If we add them together, some of the trajectories, some of the action lines will go positive, some negative, and as a result, you will get interference with this positive and negative blobs. So as soon as your wave packet starts moving, so very first few steps, it just moves downhill, and then it develops this up and down things, right?
Yeah.
So it is a consequence of we are trying to connect classical world where everything is clear to the quantum world. And major philosophical benefit of your work that you told it in your writing. You know, we are trying to find quantum corrections to classical trajectory. And sometimes these trajectories are exceeding they like corrections are bigger than the main effect.
Okay.
So those complicated structure, that there is a chance that instead of going directly like OH approaches a catalyst, connects to NO and then together departs from iron, instead they two makes chaotic motions, and the product never leaves the catalytic side. It just stays oscillating near the iron. So this is also possible. There is a non-zero probability of such event, and you are evaluating simultaneously several of these possibilities. So this distribution of blobs in this area means that there are multiple trajectories going on. Okay, and if system doesn't go from reactant to product, you're not guilty. Richard Feynman is guilty, Niels Bohr is guilty, Erwin Schrödinger is guilty. So it's just laws of quantum theory.
Okay.
You are exploring how the account of quantum effects modifies interpretation of reaction. Okay. Better?
Would in theory the path, I guess, or the trajectory that the simulation creates be similar to either the solid or dashed lines that we have sort of the predicted trajectories?
It would be a rare finding and a big surprise and success if they coincide.
So it's not strange that they don't.
No, it's typical that they don't.
Okay.
If the ridge, if the canyon will be very, very narrow and straight line, then they would likely coincide. But since it is like curvy pathways, it combines translational and oscillatory motions, and it creates a big constructive and destructive interference that you are observing. Okay.
Yeah.
I would like to suggest that Patricia invites Eva
Oh, boy.
to look on her image of the dynamics right now.
Right now,
Yes.
Me.
Not eigenstates, but the actual dynamics.
Like the video.
Yes. So what do you think of her video?
it looks funky.
But how do you interpret it?
And it looks like there's times where it's going from negative pictures, like young. I have one.
So,
Just had to call my sister to make sure her house isn't on fire.
oh,
She posted on her Snapchat story a house on fire, but it was her neighbor's house, not hers.
Oh.
so pity for the neighbor, but happy for your sister. So, in sense of trajectories, the work of wait, it's scary. So, in sense of trajectories, Patricia's work is substantially simpler than yours for a reason. Like you are going, your project has much more translational motion. And her, Patricia, can you make it loop so that it restarts? Like run, and then loop. Those. So since she didn't pour enough beer into this well, they do not exceed this little area in the bottom.
Yeah.
And it performs relatively simple oscillations. Later on, this linear oscillation changes into oscillation in another dimension, but it's substantially simpler with what you have. Right? But it is the same thing. So one can, she also could make a classical mechanics of particle moving into this position, going down here, climbing up here, and seeing what happens. But this things going up and down is what you see, this blue and orange things. And as time goes by, they develop and the signatures of quantum interference of potentially several trajectories. So we didn't cover it much in the class, but it is alternative interpretation of quantum mechanics through like superposition of several trajectories. We instead were speaking like there are fringes, and fringes are orthogonal to the direction of motion. Like there are positive and negative appearing. There is not a line here, which means it goes back and forward. And here there are just very few positive and negative things because it is low amplitude motion close to equilibrium.
Yeah.
In your situation, it is way more complicated because it accelerates going from top, like entrance to this canyon, and then going down, accelerate, and slows down, and then it gets perpendicular acceleration. So it gets like advanced structure.
Okay.
Do you feel better? Patricia, do you feel better by helping others? Okay, yes, thank you.
I have one last question, and then I think.
This better be the last one.
So I'm deciding whether I want to do this figure in my presentation.
I would appreciate it and I would vote for it.
I would like to, because it's well done, but
Not my house.
I think I get more or less explain this figure, what it means, but if anybody asks you where this tolerance, like how, what is the tolerance? So, talking about.
You can tell like one like 0.1 electron volt. You can take arbitrarily.
Would this be it? Okay. All right. All right, I won't.
If you will do it for the paper, we need to include the story.
Okay.
It is what community is used to think.
All right. All
So
right. Good to
We
know.
do a little cheesy.
Okay.
things.
No, I like it. I like it. All right. I'll put it in there.
And faculty, guests, visitors may not care, but graduate students and postdocs who do theory would appreciate this schematic diagram a lot. It's very similar to the main core procedure of computational chemistry that derives electronic structure. And polarons, as you may have already recognized, is the major subject of doctoral thesis of David Krautner.
It is.
Yes.
Oh, man. Well, I'm not looking forward to that then.
He's not yet too far, but and he may not recognize, but I assure you in a secret way that it's his major task.
Okay. Well, I hope he's not too disappointed on me. So just one last time, this figure, we're taking, in the code, the initial wave function, like the position and potential of this wave packet modeling this electron. We are applying the evolution operator to it, which updates its problem. No.
So you are special
Oh,
in respect to everyone else in the class. Well, I'll put it in a less in a softer way. Your project is special in comparison to majority of the class because your wave function that you're putting in this
yeah.
is not a result of evolution operator propagation.
Okay.
Your wave function comes from dramatically different source.
Okay.
It's not very complicated. It's very easy, but philosophically it's different thing. So let's open your write-up.
Oh, on paper.
Yeah. And just scroll. Yep.
Right on.
Mhm.
I think I have it up here. Here.
Yes. Tell me what it is, please.
Oh my gosh. So the wave function model of this electron, this polar, is dependent on the potential mostly between it and the carbon atoms acting as like cations.
But do you see any time dependence in this equation?
No, I do not.
So it's basically time independent Schrodinger equation, right?
Okay. Well, okay.
It is.
No. I understand that. So. Okay, so then it follows, this wave function follows the time independent Schrodinger equation to update its new position and potential.
Yes.
Okay.
So everyone else does time dependent propagation of wave function, and you are doing self-consistent procedure. So self-consistent optimization of combined electron density and interatomic distances in your model. And this refers to the equations in your paper, right?
Yes.
Or so you find Schrodinger equation and find
I don't know.
density.
If these are quite the same as. Okay, so this is.
One can put equations, but then it will be a little more bulky. Like 3 is Schrodinger equation. One can copy paste and put it instead of equation 3.
Okay.
And
then I think the other one was 4 and 5 to update the position. So here, yeah.
Okay.
Okay, yeah. Makes
So
sense.
the change of, and let's go back to Schrodinger equation in your paper.
Yeah.
So as any Schrodinger, number 3. So as any eigenvalue problem, it has multiple solutions, right? By I, E, I. But we are looking for the lowest for the ground state. So we need only one orbital. By I equals 1.
Okay, yeah,
Right? So whatever potential is, it dictates what will be the shape of the ground state wave function.
okay,
So positions of ions dictate potential and shape of the wave function. But the wave function defines Coulomb attraction and dictates modification of the positions of ions.
okay.
So they like affect each other, but again and again and again, and finally, like when people live together for a long time, they stop sometimes stop insulting each other and find gentle way to interact.
Okay.
Sometimes it doesn't
Yeah.
happen, but so
Yeah,
I,
like when the dielectric constant is too high and there's not enough
interact.
force between the cations of the electron, right?
Mhm.
Okay, cool. All right, cool. I think I'm good to go.
Okay. I'm just looking how this blurring is.
Oh, now it's focusing on the speaker.
Speaker, come up.
Well, you're a sprite on on an internet video. Like
Like the background.
What?
Oh,
Like,
here,
it's
I
like a
just
person
printed that
on
shit.
a green
I
screen
totally-
up in front of like
Totally
a website, and they just like
And I just.
I
picked
see.
it.
put their hand up and it's
I
like.
usually
clicking
just
on
do,
something.
I
Yeah.
just do it without it usually. But it's different in the app, yeah, but design it, you can just go through. I mean, pretty much any of these, yeah, you can go to here and then scroll down. But
This is
I'm not sure exactly how to work it on the app, but I know that's how you.
quite something.
Like for the whole presentation.
So next year is different from many years in a row. Typically, at this point, I'm trying to serve as a commercial agent of myself and invite everyone who took this class to take optional Chem364, which guarantees a peer review paper at the end of the class. But this time it is a year is skipped, so so it will be only 24. And probably I'll send you email reminders in a year telling like, would you like to join the class and try to explain benefits of this class, but no, it's too early.
Probably come back just for that.
Don't count on that.
Audit the class. We should send this to you, Dimitri.
Yes.
I am hungry.
Yeah, I'm hungry.
I could walk the Jimmy John's,
John, that's like the opposite direction.
That sounds good.
so walk the other way.
What if,
But
I need to try them on.
it's not actually that
what
close.
if I come with you and we drive my car?
I mean, that would work too.
And I can order Jimmy John's right now and it'll be ready by the time we get there.
Okay.
Fred will have to wait.
Fred, do you have the Jimmy John's app? I like the app because you get.
I just got the Flyboxers rewards.
I don't get Jimmy John's often.
If you get the app and you use it one time, the second time you use it, your sandwich is free.
Oh,
That's kind of amazing.
Yeah,
wow.
but it's only when you first use it. That's a one-time offer.
But
But
if you get a, take over and do login.
maybe.
I suppose if you make a new login, yeah.
That's really extra though, Fred.
What?
So that's really extra for you to do.
I mean,
Free
for free food?
Come on.
You have to make a new email every time.
Just use
I already
burger
have, like,
email.
4 emails. So,
So you can get 4 free sandwiches.
yeah, that, I mean, better than 1 free sandwich.
You know, I'm gonna order the exact same thing I got.
Now I can recognize what you're talking about.
We're talking about Jimmy
Do you
John's.
like Jimmy John's, Dimitri?
You been there?
$1 off a combo.
Jimmy John's?
It's like pizza side.
No, Jimmy John's is sandwiches.
Hmm.
Papa John's is pizza.
Papa John's is all right.
Papa John's versus Jimmy John's.
How do I ever?
I would take Jersey Mike's over Jimmy John's.
I never know what to pick. I'm always stuck between
I get this.
the Italian nightclub and the ultimate porker.
Italian nightclub?
Yeah,
Have you ever been to an Italian nightclub?
I have not been to the nightclub in Italy.
I don't.
But I think we are done, right?
Yes.
All questions are clear.
I think so. Now I just need to make sure I know all the information. You know, I can say it in a sort of speech way.
And I'll tell you another trick about this unbiased questions and how to interact confidently and aggressively. I'm not telling you it is a universal, but sometimes people who are asking are not confident what they, and you can like, would you like me to write an equation? And this can calm down a person who is asking. Sometimes they do not want to learn more, they just want to hear something what he thinks. So you can try to scare. Or like when someone asking a question, you know, can you define your question in a way of form event? And I will answer in the way of equation.
Mm.
And
Yeah, like
there is a yeah, you can scare off
Okay,
a person who asks the question.
they're gonna ask a question, you can be like, let me ask you a
Okay,
question.
Fred, are we serious? Because I'm gonna put in my order.
Yep, me too.
Okay. Are you coming in, Bob? Or are you gonna go?
I have food. I need to eat before I leave.
Our fridge has nothing in it except for a bag of celery and
You would.
a bag of tortillas that's been in there for like 6 months.
What can you make with that? Moldy tortillas and the soggy celery? Mm, just munch on the celery.
Yeah.
Does this chair stay here or do we move it?
I think it stays here now. I think it belongs here.
She's good. Next class or whatever.
Yeah, it's not our problem anymore. This is our legacy.
So this is the first of them, change in the equilibrium position. For transition of energy from molecular solutions to fluid solutions is dynamics. What you did show to ever like that.
But like,
And
I've forgotten what it is now.
Oh, no.
But I haven't heard.
eigenstates.
But you forgot it. You forgot your own legacy.
I forgot.
N equals one.
forgot
N
exactly
equals
what it
one.
is, But I think
Energies.
there is something that is reminiscent of me that will stay here.
I love that.
Actually, I'm so happy we discovered it now, not tomorrow.
Bro, I need to do some deep breathing or something. Do a power pose before my presentation.
This is the presentation time's 11 o'clock, right?
Right, right.
Correct.
Just wanted to make sure that I don't oversleep.
Are we carpooling tomorrow?
We can.
I would like to.
I mean, I was honestly just gonna take the bus.
I don't know how much I trust the bus anymore after a snowstorm.
Just try to get on the bus at like 7 and then by 11 you'll make it.
Yeah.
I'm taking the bus.
But it is your first meeting in the day. You do not have things before.
Correct.
So you will be fresh.
Oh,
Probably should be.
we finally have a free Friday. I can actually go to group meeting this week. I haven't been to group meeting one time this semester.
Really?
Yeah, because it's Fridays at 11.
Oh,
I've been to 2 group meetings this semester.
Brad, how many
I
group
don't think I
meetings?
missed any.
Yeah,
Yeah.
I did go on Monday, but
I mean, to be fair, though, ours are on Thursday, and I don't have anything on Thursday, so. I don't really-
It'd be funny if I go to group meeting on Friday and it's the day that my section of project is supposed to present.
Another little announcement, maybe for like, next year. For Sam, it is for this year, for likely for you guys next. So on the February, there is a conference of physical and computational chemists that I like encourage everyone to join and attend. Maybe and Sam has already signed up, and there is a like award competition. So if you are planning to attend, since you were you submit an abstract and then a petition to get an award. And then the organizers cover your travel. Just keep it in mind, and I'll bring this up again. Maybe if you're really interested, you can try to squeeze in now, or if you're not in a rush, you can do it next year. Okay.
When is it? Like when in February?
12 to 17. Okay, yeah, it was my great pleasure interacting with you. We stay same university, same city, but tomorrow will be very hectic, not enough time for emotional expressions.
visit you.
Anytime.
Yeah, I might be really bored over winter break at the lab with lots of extra time. So that would be actually a good opportunity to rerun my experiments for the ready.
Mhm.
Molecule.
And I failed to provide like data from helpers, but if you look on it for a long time, you can provide more help from helpers. We'll just show you how to generate this data.
Okay.
Yeah.
I will see you tomorrow.
Yeah, see you tomorrow.
Foul.
Yes,